In question number 4, the number of chocolate chips in a particular brand of cookie is normally distributed with a mean of 19 chocolate chips per cookie and a standard deviation of 2.4 chips. When the cookies come out of the oven, only the middle 90% in the terms of the number of chocolate chips are acceptable. The rest are considered defective. What are the cutoff numbers for the number of chocolate chips in acceptable cookies? Give your answers to 3 decimal places. What we want to find in this question is the middle 90%. Now, if the middle is 90%, we are trying to find the X values that would cover 90% of those chocolate chips. Now, if the middle's 90%, the outsides would be 10% total. Therefore, this must be 0.05 because this is 5% each. So let's go to our Z table and find the corresponding Z values that will give us 0.05. Now there's two numbers that are very close to 0.05. There's 0.0495 and 0.0505. These are equally close to 0.05. So I am going to use what's between the two. We have a Z of negative 1.64 and a Z of negative 1.65. So what's between these two numbers? Well, we'll take the average. Negative 1.64 plus negative 1.65 divided by 2, I would get negative 1.645. So that's the Z-score that we're going to use, negative 1.645, because that's the average between the two numbers that are the closest to area of 0.05. So we'll use negative 1.645 for the first Z-score, and by symmetry, I'm going to use positive 1.645. Positive 1.645 because this is symmetric. Now let's look for our mean. We know the mean is 19, and we know the standard deviation sigma is 2.4. So now we can plug it into the formula and we could solve for x. We have negative 1.645 equals x minus 19 divided by 2.4. Let's multiply both sides by 2.4. The left side gives me negative 3.948, and this gives us x minus 19. We'll add 19 to both sides. X is equal to 15.052. So that's our first solution. We need to do it again, except with positive 1.645. Let's multiply both sides by 2.4. That gives us 3.948 equals x minus 19. Let's add 19 to both sides. X is equal to 22.948. So this is the number of M&Ms that will capture 90%, the middle 90%, between 15.052 and 22.948. Our area is 0.90. Our mean is 19. Let's enter the standard deviation to 0.4. Now we'll click between, and this is our solution, 15.052 and 22.948. Let's check our work on the worksheet. Is it the same? Yes, it is. It's exactly the same, 15.052 and 22.948. So we know we did it right. We just confirmed it on the inverse normal calculator. For question 5, a manufacturer knows that their items have a normal distributed lifespan with mean of 11.8 years and standard deviation of 3.2 years. The 7% of items with the shortest lifespan will last less than how many years? Give your answer to one decimal place. I want to find the x value that will give us an area to the left of 7% or 0.07. Now to do that, we'll have to find the z-score that's associated with 0.07. And the closest number that I can find to 0.07 is this number, 0.0694. That's closer than this one. So this is the z-score we'll use, negative 1.48. So that's the z-score. We're going to use negative 1.48 for the z-score. That's the closest area to 0.07. So this z is equal to negative 1.48. Negative 1.48. So let's use the formula. Z equals x minus mu divided by sigma. We have negative 1.48 equals x minus, the mean is 11.8. The standard deviation is 3.2. So we'll use 11.8 here divided by 3.2. Let's multiply both sides by 3.2. We have 3.2 times negative 1.48 is 4.736. This is negative 4.736 equals x minus 11.8. Let's add 11.8 to both sides. X equals 7.064, which we're going to round to 7.1. So we know the lifespan less than 7.1 years makes up 7% of the population. I want to check my work, so in order to do that, I'm going to go to our inverse normal distribution calculator. I want the area to the left to be 0.07. The mean is 11.8. Our standard deviation is 3.2. We want the area to the left, so let's click below and we'll recalculate, and that is 7.077. That's exactly the same answer that we have, or very close, so I know we did this question correctly. So you could always check your work on the calculator or do the work by hand. It's up to you. Question 6. A particular fruit's weight are normally distributed with a mean of 635 grams and a standard deviation of 23 grams. The heaviest 16% of the fruit weigh more than how many grams? If you look at the question very carefully, we're looking for the area to the right being 16% or 0.16. So we need to find the z-score that gives us the area to the right of 0.16. So I could subtract from 1 minus 0.16 to find this area, and that area is 0.84. Now let's go to our Z table to find the closest area to 0.84. The closest one to 0.84 is 0.8389, and the Z that we're going to use is 0.99. So that's the Z score that gives us the area to the right of 0.16, or the area to the left of closest to 0.84. So let's go back to our worksheet. We're going to use a Z-score of 0.99. We have x minus mu divided by sigma is equal to our Z-score. So let's say 0.99 equals x minus mu, which is 635, divide sigma, which is 23. Let's multiply both sides by 23. 23 times 0.99 is 22.77, and that's equal to x minus 635. Let's add 635 to both sides. X equals 657.77. So this is our solution, 657.77. And we want to round that to the nearest gram, so let's say 658. So 658 grams is our solution. Now let's check our work with our inverse normal distribution calculator. The mean is 635. The standard deviation is 23. Now I want the area to the right to be 0.16. So make sure you click the above, so that gives us the area to the right. And that is pretty much the same answer, 658. So we did a good job on the problem. We know we did it right. So please check your work with your statistics calculator to make sure you did it right.